And the question is, which tool do you use when? So when I'm seeing a fraction, just some things I keep in my mind when I'm trying to approach to decide which way I want to do this. The techniques that we have so far, we still always check to see if a U sub works. We always check to see if a U sub works first. And obviously, looking at example number 1, a U sub is not going to work. We also talked about back in section 1 that plus minus trick. Remember, if we had an x over an x plus 5, for example, in the denominator, we would add 5, subtract 5, and then we could split the fraction apart. That obviously isn't going to work on this particular problem either. So we also look for inverse trig. Is it set up to possibly be an inverse trig, which obviously in example number 1 right now, we're not looking at an inverse trig. So we'll talk about partial fraction decomposition next week as another strategy to use when dealing with integrating a rational expression. So for right now, if you can't factor the denominator, because if you can factor the denominator, that's when we'll probably lean on that partial fraction decomposition that we could approach next week. If you can't factor the denominator, that's when we'll look at trying to complete the square. So if you take a look at example 1, you agree with me, x squared minus 2x plus 10 cannot be factored. So the strategy I'm going to use is I'm going to try and complete the square on the denominator. So if I take a look at x squared minus 2x, and I'm just going to separate this plus 10 for right now. Again, what I want to do is I want to create that perfect square trinomial on my x squared and minus 2x, pulling that 10 outside for right now. It's still going to be a part of the denominator, but I want to complete the square on my x's. So what constant am I going to have to add to create the perfect square trinomial? 1. So I'm going to add 1 here. Now remember, I can't change the value of this denominator. So if I'm adding 1, I'm going to have to also subtract 1 to keep my denominator equivalent. I'm just changing the appearance. I can't change the value. So again, I can rewrite now this binomial as an x minus 1 to the second power plus 10 minus 1, which is a 9. So I'm just changing the appearance of the denominator into 1 over x minus 1 squared plus 9 dx. When you do this, you have that something to the second power. What you should be thinking about now are those inverse trig integrals. So this could possibly be set up as what type of inverse trig? Inverse tangent, exactly. But to be an inverse tangent, the constant that I'm adding to the base squared has to be a what? 1. So remember what I'm going to do is I'm going to factor a 9 out of the denominator. So I'll have 1 over 9 times the quantity of x minus 1 to the second plus 1 dx. Now what constant can I pull out of this integral? I can pull out a what? Oh, I forgot to divide this by 9. Excuse me. So now what constant can I pull out of this integral? I can pull out a what? 1/9. So I have my integral of 1/9 divided by 1 over. Again, remember, to do inverse trig, I have to take this fraction and raise it to the second power. So I'll rewrite it as an x minus 1 over 3 to the second power plus 1 dx. So any questions on how I rewrote that particular denominator? Now what? What do you think? U sub. So u is going to be equal to x minus 1 over 3. My du is going to be a 1/3 dx. So I'm going to have to divide by 1/3, which means I'm going to have to multiply my constant by a 3. So I end up with a 1/3 times my integral of 1 over u squared plus 1 du. So any questions on how I've rewritten that integral? Now I'm ready to integrate. And the integral of 1 over u squared plus 1 is going to be my inverse tangent. So inverse tangent of u, again, u is equal to my x minus 1 over 3, and don't forget your c. So any questions on how we can use completing the square to help us rewrite it in terms of an inverse trig problem? All right? Again, notice the numerator. The numerator is a constant. So when you have a problem that involves a trinomial or this x squared minus x on the denominator and the numerator is a constant, that's a red flag that if you can't factor the denominator, what you're going to do is complete the square and possibly set it up as an inverse trig. Okay? So let's take a look at number 2. Now notice number 2, you also have a constant in the numerator. So obviously a u sub is not going to work with what's in the denominator. So what I'm going to do is I'm going to complete the square on what's underneath of my radical. So I'm just going to rearrange this as a negative x squared minus 4x, and I'm going to pull this plus 12 out. Now when you complete the square, because I want to complete the square on the x's, if you remember back from Algebra 2, in order to complete the square, the coefficient of x squared needs to be a positive 1 before you go through the process of completing the square. So if the coefficient of x squared is not a positive 1, you're first going to have to factor out that coefficient, which in this case is a negative 1. So that's going to give me an x squared plus 4x. And again, the plus 12 is pulled out. I'm not completing the square, including the 12. So now what constant am I going to add inside the parentheses to give me that perfect square trinomial? I'm going to add a what? 4. Did I really add 4 though? No, I really have a minus 4 here, don't I, if I was to redistribute the negative. So what am I going to do to the 12? Am I going to add 4 or subtract a 4? Add 4, exactly. So just be careful when you pull out that negative, it's really a minus 4 that you're adding in that denominator. So then I can rewrite this denominator as 1 over the square root. And I'm just going to rearrange this, putting my 16 first, minus that x plus 2 to the second dx. Which inverse trig could I possibly set this up as?
Sine.
Inverse sine. But again, what does this constant have to be in order to be an inverse trig? Inverse sine, it has to be a 1. So I'm going to have to factor a 16 out underneath of this radical. So I'll have 1 minus x plus 2 to the second over 16 dx. Yes, Jacob?
What happens with the negative from the complete square?
It's right here. So that's where the minus sign came from, right here.
But isn't the... Okay.
So I just rewrote this as, let me just put it this way over. Go back to the side here. This is negative x plus 2 to the second plus 16, correct? So I just rearranged my order as 16 minus x plus 2 to the second. Okay? What constant can I pull out of this integral? I can pull out a what? 1/4. So I have 1/4 times my integral of 1 over the square root of 1 minus, again, remember this has to be a base to the second power, so I can write this as an x plus 2 over 4 squared dx. Now what? Now what? U sub, go ahead and finish it for me. So hopefully we came up with the inverse sine of x plus 2 over 4 plus c. Again, after you do your u sub, your du is 1/4, so you have to divide by 1/4, so you end up multiplying 4 by 1/4, so that's why the constant is just the 1 in the front of the integral. So any questions on completing the square? Now let's take a look at example 3. What makes example 3 different than the other two? You have a what on the top? A variable. So right away, it's probably not going to be in the form of the other two where it's going to be an inverse trig. All right? Again, so you have to pay attention whether or not if that numerator is a constant versus a variable. A u sub still isn't going to work because if u is equal to x squared minus 4x plus 8, my du would have to be a 2x minus 4. All right? So again, I only have an x on the top, so u sub is not going to work. So I'm still going to try and complete the square on the denominator. So again, because I can't factor the denominator, so I'm going to still try and complete the square on the denominator. So x squared minus 4x plus 8. So again, I want to create that perfect square trinomial. So what am I going to add to x squared minus 4x to give me that perfect square trinomial? I'm going to add a 4. So if I add 4 inside the parentheses, what am I going to do to the 8? I'm going to subtract 4. So then I can rewrite this integral as x over x plus 2 to the second plus 4. Should be an x minus 2. Should be an x minus 2. Sorry about that. So any questions on what I've done so far? So now at this point, when you've got that numerator as a constant, what you're going to do now is when you're going to do a u sub. What you're going to want to do is you're going to want to rewrite this integral in terms of u and du. And this is a strategy we haven't seen in a while. So I'm going to take whatever's inside my parentheses, and that's going to be my u. So u is equal to x minus 2. My du is just going to be a dx. The question is, if I'm trying to rewrite this integral in terms of u and du, I still have this random x on the top. But can I take that x and write it in terms of u? Yes, because what can I do with u equals x minus 2? I can solve this for x. So then x is going to be equal to u plus 2. So now I can rewrite this in terms of u and du. So I have a u plus 2 divided by u squared plus 4 du. So now we've handled problems like this before. You see that plus sign in the numerator. So when you see that addition or subtraction sign in the numerator, what can you do with this larger fraction? You can split it. So I'm going to split this fraction apart. I'm going to split it up into u over u squared plus 4 du plus 2 over u squared plus 4 du. Let's take a look at this first integral. What are your thoughts on integrating this? Yes, Jason? A u sub, but I don't want to use the same letter u. I agree, we do have to do a sub, but we want to use a different letter because we've already used the letter u. So eeny, meeny, miny, mo, pick another letter. So how about we pick z? Z is equal to u squared plus 4. W. So dc is a 2u du. So now if dc is 2u du, what constant am I going to have to divide out? I have to divide out a what? 2. So that's going to give me a 1/2 times my integral of 1 over z dz. Now I'm going to integrate. I know how to integrate 1 over z. This is just simply going to be 1/2 times the natural log of the absolute value of z. Now, I know eventually I'm going to have to do some more substitutions. I like to go ahead and integrate both first and then worry about substituting back in. That's just the way I approach it. Any questions where I got 1/2 times the natural log of z? So now I've got to contend with my second integral. What constant can I pull out? I can pull out a what? 2. What integral does this kind of seem like I can rewrite it in terms of? I can rewrite it as an inverse tangent. But again, what does this constant have to be? This constant has to be a 1. So again, I'm going to rewrite this as 2 times my integral of 1 over 4 times the quantity of u squared over 4 plus 1 du. What constant can I pull now out of this integral? I can pull out a 1/4. So I end up with 2 over 4, which I know will reduce to 1/2. So I've got 1/2 times my integral of 1 over u over 2 to the second power plus 1 du. Now what? So I know I have to do some kind of substitution on u over 2, don't I? Let's not use u. Let's not use z. Let's pick another letter. So I'm going to go ahead and pick the letter v.
Q.
Or whatever letter you want. If you want to use q, go right ahead. So v is equal to u over 2. dv is then going to be a 1/2 du. So I'm going to have to divide out a 1/2, which means I'm going to end up multiplying 1/2 by 2. So now I've got the integral of 1 over v squared plus 1 dv. And again, when I integrate this, this is going to now be my what? It's going to be my inverse tangent of v plus c. So when you split these fractions up, guys, you don't want to use the same letter when you have to do more than one u sub in the same problem. So any questions on where I've gotten up to this point? But remember, my original problem was not in terms of z. It was not in terms of v. So now this is where I'm going to bring back in my substitution. So 1/2 times the natural log. Remember, z, and I do this in 2 steps, z was equal to u squared plus 4. So I'm going to bring back in that u squared plus 4 plus inverse tangent. Remember what I set v equal to. V was equal to u over 2. So now I go back to that original u sub. Remember, u in the very beginning was equal to x minus 2. So I have 1/2 times the natural log of x minus 2 squared plus 4 plus the inverse tangent of x minus 2 over 2 plus c. And there's my final answer.
This will plug the denominator back into u squared plus 4. So that we just know that's what made our initial u sub.
My original u sub was u squared plus 4.
Oh, okay. I mean, can we go back and u goes back to what that substitute was?
That was my original u sub. Yeah. Yeah. Okay? That's why you want to make sure you label really carefully at the beginning what u is equal to, what those letters are. Okay? All right, guys, last one. Shh. So, examples 1, 2, and 3 were indefinite integrals. Again, let's take a look at a definite integral. Now, again, take a look at the numerator. The numerator does not have a variable in it. The numerator is a constant. So this is probably going to be set up. Again, I can't factor the denominator. A u sub doesn't work. So it's probably going to become one of my inverse trigs. So what I'm going to do is I'm going to complete the square on what's in the denominator under the radical. So again, I got a negative x squared plus 6x. To complete the square, what does the coefficient of x squared need to be? It needs to be a positive 1, so I have to factor out a negative 1. So in order to complete the square, what am I going to have to add to x squared and minus 6x? I'm going to have to add a what? 9. But I really didn't add 9, I actually subtracted 9. So to keep this in balance, I'm going to have to make sure I add 9 on the outside. So when I factor this, I've got negative x minus 3 to the second plus 9. So I can rewrite this integral from 0 to 3/2, 1 over the square root, and again, I'm just going to put my constant first, 9 minus x minus 3 to the second power dx. I'm sorry?
Did you just put the negative like in between the numbers?
Yeah, I just switched the order, so I just again wrote this as 9 minus x minus 3 to the second. Again, what does this set up to look like? It looks like it's going to become a what? Inverse sine. But what does this constant needs to be? It needs to be a 1. So I'm going to factor that 9 out. and that's going to give me a 1 minus x minus 3 to the second over 9 dx. What constant can I yank out of the integral now? I can yank out a what? 1/3. So I have 1 over the square root of 1 minus, and again I'm going to write this as an x minus 3 over 3 all raised to the second power dx. Now what? I'm going to have to do a what? U sub. So u is equal to x minus 3 over 3. My du is going to be a 1/3 dx. So I have to divide out a 1/3, which means what am I going to do with 1/3? I'm going to multiply by a 3. So I have my integral of 1 over square root of 1 minus u squared du. Now I'm ready to integrate. And again, don't forget my bounds are from 0 to 3/2. So then it's up to you, ladies and gentlemen. Since you did do a u sub, you can change your bounds. Or remember, it is okay to go ahead and integrate and then just replace u with x minus 3 over 3. That's up to you. Either one, you can still get the right answer. So again, if I went ahead and integrate, I'm going to integrate this as the inverse tangent of x minus 3 over 3. And again, I'm going to evaluate this from 0 to 3/2. Inverse sign, yeah. Just make sure you're awake. Like I said, shh. It's an eeny, meeny, miny, mo. It's a toss-up whether or not you want to change your bounds or leave them in terms of the original bounds and then just replace u with that original u sub. You can get the same answer either way. Yes, Andrew.
If we don't put our balance on every single one of our things in our equation, but we still put it in, would that be like taken off of the
Perhaps. Okay. Any questions on that? So now I'm ready to go ahead and evaluate. So again, inverse sine of 3/2 minus 3 divided by 3 minus your inverse sine of 0 minus 3 over 3. What is 3/2 minus 3? Negative 3/2, and negative 3/2 divided by 3. 0 minus 3 is negative 3 divided by 3, so that's going to be the inverse sine of negative 1. Now I've got to remember all those lovely inverse values. You can come step in my pre-calc class and that's what they're. Inverse sine of negative 1/2. Negative pi over 6. Inverse sine of negative 1 is? Negative pi over 2, so it's going to be plus pi over 2. And there's your final answer. Okay? So again, any questions on